one of the intriguing aspects of the biomarker game has been the utilization of circulating free DNA to be able to look at therapies and whether or not it might be able to predict survival, and to be able to look at these changes in the circulating DNA and determine whether or not it might be able to look at prognosis. And we're in a very evolutionary time right now. It turns out that the technologies are evolving, that what we do today may not be the same as what we do tomorrow, but it's provocative to see what some of the preliminary results might be. And I'm going to quote from some of the other groups as well as our own. So if you look at Jan de Bono and colleagues, Gerda Tard and colleagues at Royal Marsden, clearly showing that androgen receptor amplification and certain mutations may be linked to abiraterone responsiveness. Go to Kim Chi and colleagues in Vancouver, and they pretty much showing the same thing with the amplifications in a relatively small study with enzalutamide. And we've been able to aggregate a series of centers who are now cooperating to be able to look at circulating free DNA and prognosis under various circumstances. And we have preliminary data that the number of mutations matter, that the type of mutations matter. And this is very much of a first blush type of analysis that we're going to be drilling down in much more detail. Our group at Tulane was able to discern some distinctions between androgen receptor alterations and RAF alterations, which had not been shown before. We clearly believe these are clinically significant. And as we go forward, really the relationship between these circulating free DNA alterations, prognosis, prediction with relationship to certain therapies is going to be key and I think very important.